good morning to all of you. Hope I am audible and my screen is visible to all of you. So this is the second lecture of Dalembert's principle. Before starting today's lecture, let me just give you a brief recap of what we have done in the previous class. If you remember, in the previous class, before starting this Dalembert's principle, we have talked about statics and dynamics. We have defined what is a static and what is a dynamic. Okay, and then we have classified dynamics further into two categories. One is known as kinematic and the second one is known as kinetics. And then we have defined our Dalembert's principle, and we have seen that Dalembert's principle comes in the category of kinetics portion. After defining Dalembert's principle, we have solved few problems related to Dalembert's principle. The first problem is this problem, which you can see in the slide. This we have solved in the previous class, and the second problem, which you can see in the slide, this problem also we have solved in the last class. In today's lecture, let us solve few more complicated problems related to Dalembert's principle. Okay. Let us solve in continuation the third problem related to Dalembert's principle. What is the problem? The problem is a block of mass 50 kg, resting on a horizontal plane is required to give an acceleration of 2 meter per second square towards right by applying a push force P at an angle of 45 degree with the horizontal. Full stop. Assuming that coefficient of friction between the block and the plane is 0.4, work out the magnitude of push P, obtain the solution by Dalembert's principle. Once again, I am repeating the question for you. The question is, a block of mass 50 kg resting on a horizontal plane is required to give an acceleration of 2 meter per second square towards right by applying a push force P at an angle of 45 degree with the horizontal. Assuming that coefficient of friction between the block and the plane is 0.4, work out the magnitude of push force P, obtain the solution by Dalembert's principle. Once again, if you see in this problem, diagram is not given to you in the problem. By reading the wording of the problem, you need to frame the diagram and then you have to solve the problem. So first, let us draw the diagram by reading the problem, and then we will solve this problem. So we are solving third problem. So let me write over here problem number 3. Okay. What is the problem? In this problem, a block is given to you which is kept on a horizontal plane. Let us draw that block. So there is a block and this block is kept on a horizontal plane. Okay. And this horizontal plane is not smooth, it is rough, because coefficient of friction between or at the contacting surface of the block and this horizontal plane is given as 0.4. Okay. What else is given in the problem? Mass of this block is given to you. So let me write mass of the block small m is how much? It is 50 kg given in the problem. Coefficient of friction between the block and the horizontal plane is how much? 0.4. So let coefficient of friction is denoted by symbol mu. Mu is equal to 0.4 between the block and the horizontal surface over which the block has been kept. Okay. Now again, if I read the problem, it is written that we need to give an acceleration of 2 meter per second square to this system towards right. That means when you give an acceleration of, say suppose acceleration is denoted by small a, acceleration is how much given? 2 meter per second square. So when you give an acceleration of 2 meter per second square to this block towards right, what will happen? The block will move in the right direction. That means this is the motion of the block. This is the motion of the block, because in the problem it has been told to you that you are providing an acceleration of 2 meter per second square on this block in the right direction. So this is the direction of motion of this block. Okay. And how you are giving this acceleration of 2 meter per second square? It is again written in the problem that by applying a push force P to this block at an angle of 45 degree with the horizontal. So if you want to give an acceleration of 2 meter per second square on this block in the right hand direction, you need to apply a push force P at an angle of 45 degree somewhat over here. This is the direction of push force P, and how much angle it is making with the horizontal? It is making an angle of 45 degree. So if you apply a push force P at an angle of 45 degree with respect to horizontal on this block in this manner, then only the block will move in the right direction. Clear? What we need to find out in this problem? We need to find out the magnitude of this push force P. So how to find out? We need to use Dalembert's principle, and before using Dalembert's principle, first let us draw the free body diagram of this block, and then we can apply Dalembert's principle on this block. So let us draw the free body diagram of this block. So again I will draw the block. This is the block. Okay. Now on this block, what all forces are acting? First force is the weight of the block acting vertically downward from its center of gravity, that is W, weight of the block, and it is nothing but equal to mg. Since the block is kept on this horizontal plane, the horizontal plane will give a reaction to the block in the vertically upward direction. This is that reaction force R. Fine. From the diagram which we have drawn, by reading the wording of the problem, there is a push force P acting at an angle of 45 degree with respect to the horizontal. Just draw that push force P. This is that push force P making an angle of 45 degree. That means this push force P will have two components, and those two components are P cos 45 along horizontal direction and P sin 45 along vertical direction. So these are those two components of push force P. This is the horizontal component, which is your P cos 45, and this is your vertical component P sin 45. Okay, what all forces will act on this block? Since the surface, horizontal surface over which this block has been kept, that is not a smooth surface but that is a rough surface, so a frictional force will act at the point of contact, and the direction of frictional force is in the opposite direction to the direction of motion of the block. Since the block is moving in this direction, so frictional force at the point of contact will act in this direction, and its magnitude will be how much? Frictional force F, its magnitude will be mu, that is coefficient of friction present between the block and the horizontal plane surface, and the normal reaction which the horizontal plane surface is giving to this block, that is R. So this is the magnitude of frictional force, mu into R. Is my free body diagram is complete? No, it is not complete. Why? Since the body is in motion, and if I need to bring this body, or if I need to keep this body in dynamic equilibrium, then I know that I need to use Dalembert's principle. Then according to Dalembert's principle, we need to introduce an inertia force to this block. Then only that and once you introduce this inertia force, then only the body, the entire block will be in dynamic equilibrium, and I know the direction of inertia force is opposite to the direction of motion of the block. So since the motion of the block is in right hand direction, so or is in right hand towards right end, so the inertia force on this block will act along negative x direction or along left side. That is, this is the direction of inertia force acting on the block. Let me denote inertia force by Fi. Small fi is equal to mass of the block into acceleration with which the block is moving. This is the inertia force. Now the free body diagram of this block is completed. What we need to find out in this problem? We need to find out the push force P. How we can find out? If we write down the force equilibrium equation for this block so what will be the force equilibrium equation? That is summation Fx equal to 0 and summation Fy equal to 0. Summation Fx equal to 0 is what? Taking the summation of all the forces acting along x-axis, and summation Fy equal to 0 is what? Taking the summation of all the forces acting along y-axis and then making it equal to 0. So let us write down summation Fx is equal to 0. Okay, so let me write down summation Fx equal to 0 first. कौन कौन सा फोर्स आएगा जो x डायरेक्शन में लग रहा है? दैट इज one force will be your this force P cos 45, and it is acting along positive x direction, so sign will be plus. So P, I am writing cos 45 as C45. P cos 45. Okay, C means cos, and if I write S means sine means S. So P cos 45 minus this frictional force, because it is acting in negative x direction, so it will be minus mu r minus this inertia force. It is also acting in negative x direction, so I will write minus inertia force, that is ma, is equal to 0. So cos 45 is how much? Further, let us solve this equation. Cos 45 is how much? Cos 45 is 0.707. So let me write it as 0.707 times of P minus, what is mu? Mu is coefficient of friction given in the problem, that is 0.4 minus 0.4 times of capital R minus m is what? M is the mass of the block, that is also given in the problem. It is 50 kg. 50 into acceleration with which the block is moving, that is also given in the problem. You see, acceleration is 2 meter per second square. So A is 2 equal to 0. So further you solve this equation. What we will get? We will get 0.707 times of P minus 0.4 R minus 0.4 R. 50 into 2 is 100, and if you take it on the right hand side, it will be equal to 100. So this is your say equation number 1. This is your say equation number 1. Similarly, we will write down force equilibrium equation along y-axis. That will be how much? That will be summation Fy equal to 0. Let us write it down. Summation Fy equal to 0. That is summation Fy equal to 0. So कौन सा force F direction में लग रहा है? Those forces are, one is this force, that is P sine 45. It is acting in negative y direction, so sine will be minus P. I am writing sine 45 as S45. S45 means sine 45. Minus P sine 45. Then this force, reaction force, which the horizontal surface is giving to the block, and this reaction force is acting along positive y direction, so it will be plus R minus the weight of the block, and this weight of the block is acting in negative y direction, so it will be minus mg. No other forces are present along y direction, so it will be equal to 0. Let us further solve this equation. What is sine 45? Sine 45 is 0.707, so it will be minus 0.707 times of P plus R minus M is how much? M is the mass of the block. It is given in the problem, that is 50 kg. 50 into G is acceleration due to gravity and its value is 9.81. 9.81 equal to 0. So if we further solve this equation, what we will get? We will get minus 0.707 times of P, then plus R, plus R. 50 into 9.81 is how much? 50 into 9.81 is 490.5, and when you take it on the right hand side, it will be equal to 490.5. So let this is equation number 2. Let this is equation number 2. So you are having two equations and two unknowns, that is P and R. Solve these two equations, you will get the value of P and the value of R. But in this problem we need to find out only the value of P. So just solve these two equations, you will get the value of P and R. So after solving these two equations, the value of this force, which force? The value of push force P, how much we are getting? The value of push force P we are getting as 698.25 Newton. 698.25 Newton. So this is the answer of this problem, and in this problem you need to find out how much is the magnitude of push force P you will apply on this block, so that this block will move in right direction with acceleration of how much? 2 meter per second square. So this is the solution of today's very first problem. So you can see whatever I have shown you or whatever I have solved you so far, all these things are given in the slides. You can refer this slide also for your reference. So this is all about this problem. So now let us solve one more problem related to Dalembert's principle, that is the fourth problem. What is the problem? The problem is two blocks of mass 60 kg and 15 kg are connected by a string and move along a rough horizontal surface. When a force of 300 Newton is applied to the block of 60 kg mass as shown in the figure, apply Dalembert's principle to determine the acceleration of the blocks and tension in the string. Assume coefficient of friction between the sliding surface of the block and the plane is 0.25, and in this problem figure is given to you. So this is the figure. This is the figure which is given to you in this problem. Again I read the question for you. What is the question? Question is, two blocks of mass 60 kg and 15 kg are connected by a string and move along a rough horizontal surface. When a force of 300 Newton is applied to the block of 60 kg mass as shown in the figure, Apply Dalembert's principle to determine the acceleration of the block and tension in the string. Assume coefficient of friction between the sliding surface of the block and the plane is 0.25. This is the diagram given to you in this problem. So basically, what is given in the problem and what you need to find out in this problem. Basically, in this problem there are two blocks. One block is of mass 15 kg and that 15 kg block is this one. Another block whose mass is 60 kg. This is that block. Both the two blocks are connected by a common string. This is that string. This is that string. Now, on one end of 60 kg block, force of 300 Newton is applied. You can see on one end of 60 kg block, a force of 300 Newton is applied. As a result of which, what will happen? Both the two blocks, that is 15 kg block as well as 60 kg block, will move in this direction with some acceleration. How much is that acceleration? That you need to find out, as well as how much is the tension generated in this string. Let this tension is T. This you need to find out. Also, the horizontal surface on which both the two blocks are kept is not smooth, it is rough. So that is why coefficient of friction between the two blocks and the contacting surface is given to you, and that coefficient of friction is how much? 0.25 between the 15 kg block and the horizontal plane surface, as well as between the 60 kg block and the horizontal plane surface. So I hope question is clear to you. How we will solve the problem? First of all, we need to draw separately the free body diagram of 15 kg block, separately the free body diagram of 60 kg block, and then we need to write down the dynamic force equilibrium equation considering the inertia force for both the two blocks, and then let us try to find out the value of acceleration, common acceleration with which both the block will move in the right direction, as well as tension present in the string. So let us draw the free body diagram of both the two blocks. Okay. So let me draw the free body diagram of this 15 kg block. Fine. So this is your 15 kg block. This is your 15 kg block. Fine. What all forces are acting on this 15 kg block? The first force is weight of the block acting vertically downward from its center of gravity. Let that weight is denoted by W1, and W1 is how much? M into G. Say suppose M1 is the mass of first block, and that mass is how much? 15 kg, and M2 is the mass of the second block, and that mass is how much? 60 kg. That means W1 is equal to M1G. The block is kept on the horizontal surface, so the horizontal surface will give a reaction to the block in vertically upward direction. This is that reaction force, and say that reaction force is how much? R1. Okay. What else? Since this 15 kg block is connected with 60 kg block by this string, so this string will exert one tension. Say that tension force is T. This is that tension force. So this is the tension force T present in the string. Since the surface is not smooth on which the 15 kg block has been kept, so there will exist a frictional force. And what will be the direction of frictional force? Direction of frictional force is in the direction opposite to the direction of motion of the 15 kg block. Due to this 300 Newton force, 15 kg block will move along this direction or along positive x direction. Then the direction of frictional force at the point of contact will be along negative x direction. So this is the direction of frictional force. What is its value? Its value is mu1. Say mu1 is the coefficient of friction present between the 15 kg block and the horizontal surface into the normal reaction exerted by the block, and that normal reaction is R1. Fine. Is my FBD is complete? No, I haven't introduced the inertia force. I need to introduce inertia force into picture. So since the motion of the 15 kg block is along positive x direction, so the inertia force on this block will act along negative x direction. This is the direction of inertia force. F1 is equal to m1 into A. m1 is the mass of the first block, that is 15 kg, into A. A is the acceleration with which the 15 kg block will move. Now is my FBD is complete? Yes, it is complete. So the whatever FBD I have drawn just now, that is nothing but this FBD. So this is the FBD for 15 kg block. Similarly, let us draw the FBD of 60 kg block. Let us draw the FBD of 60 kg block. So this is your 60 kg block. Now what all forces are acting on this 60 kg block? The first force is the weight of the block, that is acting vertically downward. This is the weight of the block. Let that weight is W2 and its value is how much? M2 into G. What is M2? M2 is 60 kg given in the problem. The block is in contact with the horizontal surface, so horizontal surface will give a reaction force to this 60 kg block. Let that reaction force is R2. Fine. 60 kg block is connected with 15 kg block by a string. So the string will exert one tension and the direction of the tension force exerted by the string is this one, T. So for this 60 kg block, this is the direction of tension force exerted by the string. Fine. On this block, externally along the positive x direction, 300 Newton force is acting. This is that 300 Newton force. As a result of this 300 Newton force, the 60 kg block will move in this direction. So this is the direction of motion of the block. Is my FBD is complete? No, I haven't introduced the inertia force into picture. So what will be the direction of inertia force here? Here the direction of inertia force is in the opposite direction to the direction of motion of the 60 kg block. Since the 60 kg block is moving along positive x direction, so the inertia force will act along negative x direction, and it is denoted by, say suppose F2 is equal to how much? Mass into acceleration of the block. Which mass? Mass is m2, that is 60 kg for the second block, into acceleration is A. Here acceleration of both the block is same. Why? Because both the block are connected by a common string. So there will be a common acceleration for both the two blocks. So now is the FBD of my 60 kg block is complete? Yes, now it is completed. And the FBD of 60 kg block is this one. This is the FBD of 60 kg block. Okay. Now what we need to find out, basically in this problem we need to find out the magnitude of acceleration and the magnitude of tension force exerted by the string. How we can find out? For that we need to write down the force equilibrium equations for both the two blocks, and from those force equilibrium equations we will be able to find out the acceleration and the acceleration present in the system and the tension exerted by the string. So let us write down. So first of all, let us write down the force equilibrium equation, that is summation Fy equal to 0 for both the two blocks. So for the first block whose mass is 50 kg, what will be summation Fy equal to 0? It will be plus R1 acting in positive y direction minus W1, and W1 is how much? M1G. So R1 minus M1G is equal to 0. No other forces are present in y direction, so it will be equal to 0. Or I can write what? I can write R1 is equal to M1 into G. Fine. This is summation Fy for 15 kg block. Similarly, we can write down summation Fy equal to 0 for 60 kg block. So what will be the equation? It will be plus R2 acting along positive y direction, that is R2, minus this W2, because this W2 is acting along negative y direction, so R2 minus W2, and W2 is how much? W2 is M2 into G equal to 0. Further I can write this equation as R2 is equal to M2 into G. This is the force equilibrium equation along y-axis. This is force equilibrium equation along y-axis for 60 kg block. So all these things are there in the slide. See, for the 15 kg block it is R1 is equal to M1G, and for 60 kg block summation Fy equal to 0 is R2 is equal to M2G. Correct? Now let us write down the force equilibrium equation for both the two blocks combinedly. Now let us write down summation Fx equal to 0 for both the two blocks combinedly. What will be the equation? Equation will be minus F1 frictional force. This is that frictional force acting along negative x direction. So for the 15 kg block, minus F1 minus F2 frictional force for the 60 kg block. It is also acting along negative x direction, so I can write minus F2. Then I can write plus T tension force exerted by the string on the 15 kg block, and it is acting along positive x direction, so I will write plus T minus again the tension force exerted by the string on the 60 kg block, and here the tension force is acting along negative x direction, so sign will be minus T. Okay, plus 300 Newton force acting along positive x direction on the 60 kg block, so plus 300. Clear? Minus inertia force for the first block, that is 15 kg block. Why minus? Because it is acting along negative x direction, so I can write minus M1 into A minus inertia force for the second block, that is 60 kg block, and it is also acting along negative x direction. So I can write minus m2 into a is equal to 0. Or I can write this equation as, I can take minus common. If I take minus common, what I will get? I will get f1 plus f2. Again, if I take minus common from from here, what I will get? I will get minus, in bracket I will get m1 plus m2. A is common, take it out. A is common, take it out. So I will get minus, in bracket m1 plus m2 bracket close into a. Okay, this plus t and minus t will get cancelled out, and we are left out with one more term, that is plus 300 is equal to 0. Is it clear? And this equation is nothing but this equation. Okay. So now let us solve this equation. Let us solve this equation. That is F1 is what? F1 is frictional force for the first block, and it is how much? mu1 into r1. And what is F2? F2 is the frictional force exerted by the second block, and its magnitude is how much? Again mu1 into r2. Mu is common because the surface is common. Okay, so in place of F1 I can write mu1 r1, and in place of F2 I can write mu1 r2. So I can write minus, in bracket see, mu1 r1 plus mu1 r2 bracket close, minus m1 plus m2. m1 is the mass of the first block, and its magnitude is 15 kg. m2 is mass of the second block, its magnitude is 60 kg. So I can write minus, in bracket 15 plus 60 bracket close into a. See, minus, in bracket 15 plus 60 bracket close into a. Then plus 300 is equal to 0. Plus 300 is equal to 0. That is this equation. Okay. Now again you solve this equation. What you can do? You can take mu common. So when you take mu common, minus, take mu1 common from the bracket, you will get what? r1 plus r2. But how much is r1? Just now we have solved. r1 is m1g and r2 is m2g. So in place of r1 and r2, substitute m1g and m2g. So we will get minus, this mu is common, take it out from the bracket, you will get m1g plus m2g minus 60 plus 15 is 75 times of a plus 300 equal to 0. That is this equation. Okay, further solve it. Mu, coefficient of friction, is given in the problem, 0.25. okay, so minus 0.25, in bracket m1 is mass of the first block given in the problem, 15 kg, into small g is acceleration due to gravity, its value is 9.81, plus m2 is how much? Mass of the second block given in the problem as 60 kg. So 60 into acceleration due to gravity, that is 9.81 bracket close, minus 75a plus 300 is equal to 0. So just solve this expression. Which expression? Just solve this expression. Once you solve it, what you will get? You will get minus 183.9375. okay, plus 300, and this minus 75a, we have taken it on the right hand side, it will be plus 75a. So minus 183.9375 plus 300 is how much? It is 116. 0.0625. So this will be equal to 75A, or acceleration A is equal to how much? It is equal to 116.0625 upon 75. If you solve it, you will get acceleration A is equal to 1.5475 meter per second square. This is the first part of the problem. In the problem, it has been asked you to find out the acceleration with which the entire system is moving by the application of this 300 Newton force. So the common acceleration with which the entire system is moving is how much? It is 1.5475 meter per second square. Okay, one more part is left, that is we need to find out tension exerted by this string, by this common string. So how we can find out? So what you do is you write down force equilibrium equation for any of the block. I repeat, you please write down the force equilibrium equation for any of the block. Either you write down for 15 kg block or you write down for 60 kg block. Okay, so say suppose I am writing down the force equilibrium equation for 60 kg block. So what will be the equation? Force equilibrium equation along x-axis for 60 kg block, it will be how much? It will be plus 300 Newton, force acting in positive x direction. So 300 minus tension T, minus this inertia force acting in negative x direction, so minus m2 into A, because m2 is how much? 60 kg, minus this frictional force, it is also acting in negative x direction, so minus mu1 into R2. Any other force is present along x-axis? No other force is present, so equal to 0. So what equation I will get finally? 300 minus T minus mu1 R2, and bring this minus m2a on the right hand side, so it will be plus m2a. So finally you will get equation like this, that is 300 minus T minus mu1 R2 is equal to m2a. Solve this equation, that is 300 minus T minus mu1 is given in the problem, it is how much? It is 0.25 into R2 is how much? We know R2 is m2g, so in place of R2 substitute m2g, okay, minus m2a is equal to T, or I can write T is equal to 300 minus mu1 is 0.25 into R2 is your m2g minus m2 is 60 kg, 60 into acceleration A, just now we have found out it is how much? 1.5475. Or I can write tension T is equal to 300 minus 0.25 into m2 is 60 kg into g is acceleration due to gravity, that is 9.81, minus 60 into 1.5475 is how much? 92.85. So just solve this expression. You will get the value of tension T exerted by the string, and that value is how much? That value is 60 Newton. This is the second part of the problem. In the second part, they have asked you to find out the common tension T exerted by the string, and that tension T is how much? It is 60 Newton. I hope this problem is clear to all of you. Okay, then with this I end my today's lecture over here. In the next class again we will see few more complicated problems related to Dalembert's principle. Till then, thank you.